Howdy, y'all, and welcome to another high-powered episode of the High Voltage Live Show. I'm your host, Willie Snyder, with Nat King Code, coming to you live from the Mile High City, Denver, Colorado. I am joined by two of the most awesome code people on the planet, Mr. James Stallcup Sr. and James Stallcup Jr., and both of them have a great show planned out for us. I'm really excited to have Senior come on, and I'm going to learn a lot. This is a good class that I really been interested in all week, just hearing about it. And I'm really happy to have so much participation in our Myth of the Week. Every week it just keeps growing, and our group's growing. The NEC for Dummies is growing. We're over 16,000 now, and it's just growing fast. It's really awesome. About adding about 1,000 people a week.
Yeah, we're about to go over 16.5, I think. I mean,
yeah,
unbelievable how fast it's growing. We got good content, though. That's why.
Yeah, and then you got the Leviton thing, too, you were saying.
Yeah, we just found out we'll be doing the Leviton pamphlet for the new code changes that pertain to their products. And we'll be doing that. And we got a couple other things coming up. One thing could be big. I'm not going to say anything about it. I'll know more about it Wednesday. That's when we're supposed to have a podcast or a face-to-face Zoom meeting. So we'll see what happens. But nice. A lot of cool things going on. So
awesome.
That's about all I got. You ready to get started?
And this week we're gonna switch it up a little. We're gonna let Senior go and do his presentation, and we're really honored to have you, sir. And then
we are.
Then we'll
I will tell you what gave me the idea doing this. Plus, Dad mentioned it. He did a class over at BPI, which is the Building Professional Institute for all the inspectors, and they all really, really liked him doing the difference between intrinsic safety and non-incendive circuits. They said they'd never really understood that subject. And he said, yeah, he'd be more than happy to do it. And they said it was the best hazardous location class they'd ever heard. So, and that
welcome into the stream.
So
we got a few people jumping in on the stream. So welcome.
Cool.
But I would like.
It's nice to see the legend, James Sr.
I'm going to star that comment.
I would like to point out now, this is not a complete hazardous location class. We're just going over intrinsically safe versus non-incendive. So
nice.
I wouldn't want anyone to think we're covering everything.
Okay. I'll try not to interrupt you if I ask some stupid questions, right. But there might be some. There might be some,
it just like we're in a classroom anyway, so it'd be fine.
There might be some questions come up, and I'll put them up on the screen and then try to catch you when you're in the middle. So if you're out there, feel free to ask any questions you like.
Yeah, if you have a question, if I can answer it, well, feel free to ask.
All right, let me cue it up. I know you're wanting me to change that song.
Yeah, we got to
get nailed this. I'll tell you for sure.
Yeah, we got to get some metal in there. More metal.
Oh yeah. All right, let me get this queued up here. Let him get started and give him the full screen. There you go.
Well, this illustration is basically with OSHA 1910.307C2, and you can see to the right of the illustration, right below the equipment, that the OSHA loop there, I won't go over it, but that is the actual OSHA loop when it deals with intrinsically safe and non-incendive type circuitry. If you're going to approve this equipment as an inspector, for example, or even as a designer or installer, then you're not going to go to 110.2 and approved, identified, and go through that scope of the code. You're going to look at, as you know, 500.8A1 through 3 when you're approving equipment. For example, in non-incendive, it could either be listed type installation, or the authority having jurisdiction could go through it and approve it, but most of the time they want a listing, or they, 110.3B, or they want a NERDL put on it by UL or ETL or someone that the authority having jurisdiction will accept. Now, to the left is your NEC and UL standards that we would use in conjunction, which, God, we could talk about those, for 30 minutes real easy, any of it really.
Oh, yeah, absolutely.
So, as you can see then, and identified according to 500.8A1, then you see that the equipment is listed or labeled, or evidence of equipment evaluated from a qualified testing lab or inspection agency who's concerned with product evaluation. Now, most of you inspectors, engineers, and electricians, we used to use 110.3A1 through A8 for custom-made equipment and, putting equipment together in an assembly like we would do using the approved components. Right. Or it could be a NERDL put on, as you see there. But you have to be concerned with product evaluation. And if we really went through with you 110.3A1 through A8, it would take about a 7-8 hour course to do it properly when you tie in the UL standards and things that go along with it. But all I'm pointing out here is that to approve this equipment, you're going to go to 800.8A1. And one of the biggies there is that under engineering owner supervision, then this equipment could be accepted by the authority having jurisdiction by just, reading the control drawings and the diagrams and things that come with it to make sure that it all the components and things meet an installation dealing with an assembly. Let's go to the next one now, John.
So is it Article 800? Is that Chapter 8 because it's a communication circuit?
500, you mean?
Oh, okay. I thought you said 800 in there.
He did. He misspoke.
Well, if I did, I goofed up. If I said that, I'm sorry.
My bad. No.
That was a slip of the tongue.
Okay.
Okay, you ready to go to the next one?
I did.
Okay. Now, this deals with the zones, but you're going to use 505.9A1 through A3 for the zones. A lot of electricians don't like the zones. Some of you engineers and electricians, inspectors, it's how long the vapor can be there when you start reading through 505. And if it's 1,000 hours or more, it's a zone 0. But if it's 1,000 hours or less, or 100 hours or more, it's a zone 1. If it's less than 100 hours, but 10 hours or more, then it's a zone 2. If it's less than 10, then it's not considered classified. Now, that's a good rule of thumb when we look at IEC 79 to get some of that information for the zones. So that's all this is. It's just showing you we're not going to get into the zones. Go ahead. Now, purged and pressurized systems, some of you know that I chaired that committee for about 12 or 14 years due to us changing our secretary with NFPA. But NFPA 496 deals with purged and pressurized systems. And you're either type X, type Y, or type Z. Now, we won't get into that, but that would be a good presentation if you folks out there are interested in it for another little 30-minute segment that Bill and James usually gives me to go over this stuff. And if you're interested in that, tell them, and I'll do that and go through the types and the beneficial of using that type of a system for a control room or enclosure or motor. Next one.
Absolutely. Awesome.
Now, this illustration now deals with intrinsically safe. Now, in times past, they had abbreviation for intrinsically safe a little different. But the thing that we want to look at, in my opinion, I don't know how well this shows up, but if one of you out there wanted this little presentation, you can get a hold of Bill or James, and they can get it to you. But
Yeah.
notice the item 1 is select your equipment, and that's by NEC Article 504 on page 386 of the code. You know, it's really only about 2.5 pages. But if you deal with intrinsically safe IS systems, it'd be really good to go and read that very carefully, along with the ANSI and UL standards that are recommended. And then secondly, you can define this equipment that you're using in Article 100 on page 43 of the NEC. It'll define it, and we'll kind of talk about that. And then you select your wiring methods in 504.20, which can be any of the wiring methods in Chapter 3 that would be okay for a non-classified area. And we'll kind of talk about that. But you got to go to 504.20 to get those different types of wiring methods.
Hey,
and then
not to interrupt, I was just going to ask you, somebody asked a question about a certain color coding for intrinsically safe cable. Where would that be at, or what would that be?
Which kind of cable now?
Like an intrinsically safe cable. Like, is there some kind of color marking or something that is on the cable?
It would be listed if it was just specifically designed for that, just like non-incendive. You can get a non-incendive wiring method, but you can still use tray cable if you wanted to for non-incendive, and you can use any of the wiring methods here. You do not have to go to a listed intrinsically safe cable.
Okay.
And you can read that for yourself in 504.20. It's very clear there.
10-4. Okay.
Asking, is there a color code for it?
Oh, yeah. Is that what you asked for, color code?
Yes, sir. Yes.
Oh, I'm kind of having a hard time hearing you, and I'm sorry. But yeah there is a color code. It's a light blue. If you don't have a light blue color, that's 504.80.
10-4. Okay.
Yeah.
I was just curious about that.
And they'll use the light blue usually at terminals. If it's a conduit system or cable, they usually put a label on it, intrinsically safe circuit.
Gotcha. Okay.
And we're going to get into that. Yeah. Anything else?
No, that was a question one of the listeners asked. So I just wanted to bring it across to you.
Well, I had this little air conditioner on, and with my hearing aids, you were drowning out, Bill, so I misunderstood your question to start with. I've turned that off here for a minute.
That's fine. Absolutely. Okay. Continue.
And then let's see here. Oh, yeah. Now, sometimes the item number 4 in your illustration in the red is selecting your seals when necessary. And mainly in 504.70 on page 387 of the code, we would select those seals usually in 501.17 that deal, with process equipment, and where you'd have a pressure and a gas or vapor might, pass through the core of the cable and create a hazard in a non-hazardous type area in some cases. So that's where you'd want to see if you need seals or not. Otherwise, you don't at 504.70. Then the identification of your systems and circuits, as you said, is 504.80. And I believe A is your terminations, which would be light blue. And then B is your wiring method. And then when you go to C, you get your color coding of a cable, or if your conductors happen to be in a conduit, every 25 foot.
Okay.
So that is basically 5. Now 6 is grounding and bonding, and that's 504.50 on page 387, and 504.60 on page 387. And that's exactly how most of the engineers that I've talked to, installing electricians and the inspectors, that's their approach to inspecting these systems. And if we're all on the same page, and it doesn't necessarily have to be in that order, just as long as you perform steps 1 through 6, you do a decent job when you're installing these intrinsically safe systems. And then notice for the barrier, look at what it says intrinsically safe barrier, UL 12.06.01.
Yep.
There's a lot of information in there about that, and also UL 913. And then, of course, I just pointed out that 504.2, the informational note 2, was in the 2014 edition, and then everything, all the definitions were moved from 504.2 over into Article 100, and then all your definitions for intrinsically safe were put in Part 3. Now they've redone it again for the 2023. I don't know if James covered that with you or not.
Not yet. Nope.
Okay. And then notice in this illustration, I like this. It's very good for you. Notice the figure 4-18 in the boldface 501.105A or B. You know from our experience, except occasionally, A is always Class 1 Division 1.
Right.
B, if you see B, it's always Class 1 Division 2. I know you guys know that, so if I get too simple, just ignore me. But we pick up instruments, relays, and meters there. And out in the oil industry, refineries, we pick up a lot of instruments with intrinsically safe equipment in a Class 1 Division 1. But, of course, you're going to have a lot more maintenance in accordance with NFPA 70B, and I believe it's Chapter 35. It's either 35 or 27. Okay. And then if you pick up 501.150A and B, you're dealing with Division 1 or Division 2, and you're picking up communication circuits, signaling circuits, control circuits, alarm circuits, and the other circuits that do not fall in 501.105. So those are two sections that engineers, electricians, and inspectors need to know, and I know you do know it, so don't take it wrong that I'm saying you don't. Those you should master because they really tie in big time with intrinsically safe and non-incendive type circuits. Let's go to that next one now.
One thing I was going to...
main difference.
Oh, not to interrupt. One thing I was going to say to our listeners out there is if you want, you can go to Product IQ and set up an account, and you can look up these UL standards. That's the new software. That's the new place where you could go to look up UL standards. So I was just,
good. That's good information. Know. Yeah, that's good information, and sometimes you need a standard. You know, when you look at the NEC just lets us know as electricians and engineers that we have a problem. You have to go to NFPA 497 to solve it if you're in a chemical plant, and if you're in, say, a refinery, oil and gas, you go to the API 500, and you start off with the section numbers that you see there. But yeah, anybody wants to make a good comment, come on. That's what we're trying to provide here is just information.
We got one. That's the same one. It came through again. Everyone's saying they love to see you on here, Senior.
You're a legend.
Well, tell them I thank them for saying that. Let me say this. I'm old enough to be a legend. I'll tell you for sure. But now, on your wiring methods, notice 504.20. And but you'd be surprised, calls I'll get from young engineers getting started and electricians, and they don't realize that 504.20 will let you just use any of the Chapter 3 wiring methods that you could install in that place. Mainly, it's MC and AC cable that they use. And of course, they use the HV type cable that they would use, hazardous locations. But notice 500.5B 1 and 2 deal with the hazardous locations in the NEC. But you have to go to NFPA 497 to do your classification. Right. Now, if you deal with classification a lot and you're putting this equipment in, you should have NFPA 497 if you deal with gas and vapors. If you deal with a little dust, then you need NFPA 499. If you
Right.
deal with purged and pressurized systems, you need NFPA 496. And if you're a maintenance electrician, you just can't hardly do the job right if you haven't kind of gone through NFPA 70B. And you guys know if you're dealing with the 70E, the safety related work practices, 200.1, I believe it's on page 44, will send you to 70B for your PM or what? The company's PM. Either
Yep.
one of them satisfies OSHA when you go to OSHA 1910-307. I thought maybe you might
Gotcha.
like that little bit of information. And then, of course,
Yeah.
we have everything on here you guys want if you'll just get with Bill or James. And
Yeah.
if they'll send it to you, it's okay for you to have it. I don't mind you using it. It's good information, I'll tell you that. It's also, this comes from our Stallcup's electrical design book, and it's in volume 1. And then if you go to volume 2 and pick up chapter 21, it takes you all through hazardous locations and gives you a lot of tips, design tips and things that you guys have taught me through the years. I've learned so much from engineers and electricians, that work for these companies and so forth. Okay, let's
Nice.
go to the next one, James.
Yeah,
Now,
and just to let everyone know, we probably will post some of these in the group in the NEC for Dummies. If you guys just tell us what you want, we'll post it up there.
Sure, we can do that real easy.
Yep.
okay, well, that's up to them. I don't get into what James does. I've taught the boy everything he knows, so I don't mess with him anymore. I feel like he's okay now. Sometimes he gets me in a lot of trouble, though. A lot of trouble. But now, looking at basically, a Zener diode just kind of regulates voltage and allows an avalanche of current with just enough current to trip that fuse that you see in the illustration. And then the resistor limits the current rating so it doesn't damage your board in any way, see? And that's basically what they're saying. And if you want to look at your general purpose enclosures that you can use, go to 504.10C as in car on page 386, and you can kind of pick that up. Now, these systems do operate at less than 50 volts, but most all of these systems operate anywhere from 18 to 30 volts DC is basically what they operate at. Mm-hmm. And so I just threw some of that information there. And of course, if you're looking now for the definition of simplified equipment, simple equipment, it used to be defined in 504.2, but now it's in Article 100 on page 45. And if you do your calculation by 504.10D as in dog in the NEC, you can automatically fall within those parameters there. Parameters, you could use a T4 classification for your T code letter. So some of that information's there, and the procedure for using the table and everything that was in, is in our design book, volume 2, chapter 21, or you guys go look at UL 12.06.01 and UL 913. And my understanding now, they have the same kind of deal. You can look at their standards for a fee, but if you download anything, then it costs you money, naturally to do that. But your simple equipment, you can see, is 1.5 volt, 100 milliamps, and they don't even have to be on the control drawing. And 504.10 A through D. They don't even have to be listed on the drawing like everything else does.
So I have a question. So I don't know if you know this, but I was working at a peanut butter and jelly sandwich factory, and they had a lot of flour. So we had fire alarm devices that we had to install in that area, which is a class 2 div 2 area. Well, it was my understanding that those would be considered intrinsically safe because those devices operate under 50 volts.
Well, it depends on when in 70E now, in Article 110, we tell you that you have to evaluate a class 1 or class 3 circuit, but you don't a class 2.
Okay.
So you got to look at the arc of the spark. And could
Okay.
that, if that exceeds, the 80% of the ignition temperature of your gas or vapor in table 800.C,
Okay.
got a problem.
10-4. Well,
Yeah.
it was in the plant spec, so we got the fire marshal to allow us to delete it because there was enough notification in that area. But it was a kind of a can of worms, and I just thought, I don't even know. But yeah, I could see a strobe light doing that on a fire alarm strobe.
Yeah, it's that arc. And you look at two things. You look at the arc, and then you look at the heat that it could generate.
10-4.
And that's
Okay.
why they have the table 504.10D that you can run the calculation. And if you go over and look at UL 12.01 there, if my memory doesn't fail me, they have a nice little formula in there that you could use. You don't have to be no great mathematician to understand it,
Right. Yeah, we got a lot of compliments coming in on your presentation, sir.
Oh, well, good. I thank the people. I hope this stuff helps them. I've been in this old oil and gas industry practically all my life, working in it one way or the other. So those guys have taught me a lot. I've learned a lot from them. But now, one thing you want to look at here, fellas, is that in the non-hazardous area, you want to put that enclosure that has your barrier. Then it can be just a general purpose enclosure. Then you just put your seal at the boundary or the imaginary boundary. And then you notice you don't need any seals in leading there on that hazardous side.
Right.
Without its process instruments and things like that have a great pressure. But if you put that enclosure in the hazardous location to the right where you see the red, then that's to be explosion-proof enclosure. You have to seal within 18 inches of the enclosure, seal at the boundary, and then you got to seal on that other side to those high-pressure sensors that you might have there. So it's very important where you put the enclosure that house the barrier. That's location in 504.10B, and then you have the API there also.
Nice. Okay.
Now, looking at this, if you want to route in cables and tray cable, raceways, you can do that. And then notice in the illustration that you see in the call out, in the beginning, back in 1956, and I never forget when these things come into the code, and I saw that they'd been there since 1956. Don't get me wrong, I wasn't in the electrical industry in 1956, by the way. I'm not that old.
I wasn't saying anything.
Okay, I just want to pass that on.
Right.
But notice that raceways and these cable trays, under certain conditions, they isolate these cables. And then the exceptions 1 through 4, we have a AC cable, an MC cable, a cable that has a jacket that's a separator, and you comply with 504.30A1 in those exceptions, then you don't have to have the raceway or the cable tray or anything like that. I would point out to you in the cable tray, when you get in and review it over in 392, that if all your intrinsically safe circuits are the same, they can go in that tray. But say that you had two different, then you'd need a partition between them to separate them.
Okay.
So when you get into that separation, you want to, as we'll see, we got to be careful how we do that. Now, notice they used to be referred to as ITSC systems. Now it's just simply IS. And non-incendive is just simply NI. When you see that reference, I know you know that, but I just kind of passed it on.
What I can't really see what the separation is. Does it give a measurement on that separation from the intrinsically?
Yeah, 2 inches. 2
okay,
inches.
2 inches. Okay.
It's right here. At this illustration here, it's a 504.30A as an apple 2 on page 387. And then notice you need a 2-inch separation, or you need the insulating non-metallic block that separates them.
Okay. Gotcha.
Yeah, where you, like Bill, you go in, you start connecting these. If you have an insulating block, then that's considered isolating one terminal from another terminal.
Yep. 10-4.
Okay. And so
Does
that's where
does
you get.
does that have to do with your over 100 volts, over 150 volts between terminals?
It has to do with anything. You got to have those separations. If you run a
10-4.
cable, you even have to have the 2-inch separation.
Oh, gotcha. Okay. Makes sense.
Okay, I think we have it there. See, it says intrinsically circuits at least 2-inch separation.
Gotcha.
I know that's hard for
Okay.
you to see. That's why
Yeah.
I'm offering it to these guys out there, so you can look at it a little bit more in depth and realize, what's on these illustrations. I know it's hard to
Yeah.
see. Now, see, this shows you a power cable
Uh-huh.
that could be, say, 120, 208, 240, 480, 277, and it's a 2-inch separation. You see that there?
Okay.
You have to have that
Gotcha.
2-inch separation, and you have to have a insulation thickness that you would have to meet also, as we'll see.
Gotcha.
Go ahead. And then, of course, this is getting to your question that you asked. If you have a cable tray, raceway, cable, then that's where you put the label. You with me?
Yo, 10-4.
And then for your terminals in your wiring, then it's 504.80A and B. And then here's your seals when you really need them and when they're required. But now the light blue is where you make these terminations, and you're taking the conductors out of the cable. You with me?
Yep.
And then a lot of folks I've seen, they'll spray these cables with a light blue about every 25 foot to identify those from other cables. And they're telling maintenance people, you stay away from these cables without you have you're trained and qualified to service them and work on them. So
Yes,
it's
sir.
an identification type thing.
Gotcha. Okay. That makes sense.
Go. And then, of course, color coding. Then see where you terminate and everything, you're going to color code those conductors light blue. But however, I have seen out in the industry where they, instead of putting the label on every 25 foot in previous installations, they just sprayed it light blue it will be about a foot, about 12
Okay.
inches of light blue.
That
And
works.
they'd identify it in that manner. But to me, the code says you need a label on the raceway or the cable, but you can put the light blue inside where you terminate.
Okay. Gotcha.
Page
Awesome.
388 of the 504.80C. Okay. Now, this is important here. If you're out in the industry working, when you ground the barrier, you must ground either to structural building steel, that's an electrode, and if you go to 250.52 A3, or A2, I'm sorry, A2 is for
A2.
building steel.
Yes, sir.
Yeah, and I think A3 would be for your concrete encased electrode, wouldn't it?
Yes, sir.
And then you would pick up your ground ring there in A4. And any of these is okay, but a driven rod, no.
Yeah,
You're
and
gonna
I would use a number 4 for an electrode anyway.
Yeah, and usually if you go over and look at the AS standard over there, that SA standard, it kind of indicates that you need to read 1 ohm where you connect, the ground here.
Okay.
Not here at the barrier, but at the wire. It kind of indicates they like to see 1 ohm, or if you could get 1 ohm. But then they allow, with exceptions, some other things. So, but
Okay.
just make sure that your steel is an electrode. If it's not an electrode, then you got to apply 250.104 C.
Okay.
And if the water pipe is not electrode, you'd have to look at 250.104 A1.
Gotcha.
Yeah, you have to look at those to see if they're an electrode or they're not an electrode. Because I always like to look, and you grounding experts out there, always like to look at 250.50, 250.50, and
Okay.
250.52, which describes what can be used as an electrode. And then you electricians install those electrodes by 250.53.
Yes, sir.
Yes, online, beautifully laid out in a systematic order. Just 250.50,
Yeah,
250.52, and 250.53. Excuse me,
it's
Bill, come on.
it's almost like somebody got it out of somebody else's book.
They laid it out like our design.
Yeah, that did happen. I was real worried about, in the 99 code, they rewrote Article 250.
Yeah.
And when they rewrote that Article 250, it really scared me because I was on the road and I told James, I said, man, we got a hell of a problem. They've rewritten 250 and all the sections have been renumbered and relocated. But when I got to looking at it, hell, it was just like the design book. We didn't have to hardly change anything but the section numbers.
That's
So,
so awesome, man.
yeah, thank
Dude,
God for that one. But this
you-
one that they got now, fellas, you better watch that 2023. Man, they have changed and redone section numbers, added something and changed all those section numbers. It's a mess. We're going to really have to watch it. You're going to, you learn all these sections and you're going to get to learn them all again in 2023.
Yep. One thing I love about your guys' stuff is it always evolves, and so all your stuff is totally aligned to the 2023 already, and that's awesome. That's so cool.
A lot of work, boys. Of course,
Yep.
you guys know that. Well, let's go to the next one.
I
Yes,
got
sir.
one question for you.
Go.
The concrete encased electrode, the ground ring, and the ground rod. Do you size those off table 250/66?
No.
That's all we wanted to hear.
250.66A, B, or C.
That's right. Okay. You
Nice.
heard it here.
Yep. Yes, sir.
Now, if you look at really, and you grounding guys out there know this, if you look at 250.66, it basically tells you that table 250.66 is only used to size your grounding electrode conductor per code now. If you connect it to the structural steel or a metal water pipe, that classifies as an electrode in 430.52.
10-4.
Yeah, that's correct. Then you'd go 250.66A and B and C, as you guys know. All right, go to the next one.
Already did.
Yes, sir.
Oh, you already got me here.
Yeah.
Now,
Yeah.
this deals with the bonding. And I've had, as some of you guys out there, people would say, well, why in the hell do you have to bond all this, from the equipment all the way to the barrier, back to the computer, and back to the screen? Why do you have to do that? Well, the reason is
we call that the triad out in the gas and oil. Like we call it the clean ground out there.
Yeah, and the thing about it is, if you don't bond it back good, they're afraid of another energy source getting on it that's higher than the 18 or 30 and damaging those real sensitive electronic components.
Yes,
So
sir.
that's why the bonding is required, but don't ever substitute your bonding in some way. There's two things that OSHA does not allow, and you can look it up. It's in 1910 304G. And they tell you shall not substitute the equipment ground or your bonding means. No substitution.
I like
They're very
it.
clear on that. So you want to watch that. It's right there in 1910 304 GRF, one of those sections. Go ahead. And then, of course, now when we get into the nonincendive, the NI circuits, then again, how you going to approach it? Number one, select your equipment again, 500.7F through H, on page 364. And then you can say, well, I'll just define that equipment in Article 100, Part 3 on page 44.
Mm-hmm.
And then I'm going to connect meters, instruments, relays by 501.105B as in boy 2 on page 374. signaling, alarm, remote control, communication systems, and things like that. 501.150B as in boy 2 on page 377. Then select your wiring method in 501.10B3, and you can look at that in your book right now if you have your code book handy on page 370, and you can use any wiring method in chapter 3, or you could use one designed for non-incendive. But where you get screwed up on this is in the article 100, where you see these circuits defined, and it says non-incendive wiring.
Right.
But to understand it, you all know this, you got to go to 501.10B3 to get all the pros and cons here. But this is what we're looking at. The equipment enclosures, 500.7G. Enclosures with your non-incendive components, 500.7H. Your non-incendive circuits and how you could use those is 500.7F. And then, of course, if you're in cable trays, 501.10B, if that's where you have your circuitry, see.
Yeah.
So again, it's Article 100, page 44, and page 364, 500.7F, G, and H. If you follow 1 through 5, it's going to help you tremendously on this. And then you notice in the note, we have our figure loops so that you go right through the code figure loops with illustrations until you make a complete loop and come back to this very 4-29. Okay, we can go to the next one. Now notice here, again, we have 500.2, which was in the 2014 edition. 2017 and 2020 were in Article 100, and you know that's changed. Yeah. They just have them scattered out in Article 100 in the 2017, but the 2020, they grouped them all in Part 3 and added some useful ones, I thought. And then you have your 501.105B2 and 501.150B1 there that we deal with.
And so is there stuff there that moved to Article 100 in 2023?
Oh, yeah, scattered out again.
Okay.
Yeah, they're kind of scattered out in alphabetical order now, the best I could tell.
Okay.
Looking at it. And then, of course, you see your wiring methods up here. It's in 501.10B3 on page 370, where you'd have your wiring methods and you can connect equipment together. And now in the 2023, they address the power coming in, and it also can be 501.10B3, because a lot of folks say, well, that's just connecting the equipment together. Doesn't say anything about powering it, see. Okay. So basically, you guys know that the NI circuits, it's just, you can't cut a cable and create an arc. You can't drive a screwdriver through a component and create an arc, because that's not under normal operating conditions. And where people get mixed up with these things, for example, they'll go over and read on page 43 of Article 100, intrinsically safe. That's intrinsically safe systems, non-incendive systems. So people look at those and say, well, hell, we can put this in Class 1, Division 1.
Yeah.
And they've done it. The Alaskan Pipeline, they put these non-incendive circuits and all through those pump stations where it was Class 1, Division 1.
Wow.
But what saved their bacon is that they had more ventilation system than they needed. They was bringing in much more than 1 foot of clean air and removing contaminated air at 1 foot. They had much more ventilation, so they reclassified Class 1, Division 2, then all that intrinsic safe, but not intrinsically safe equipment was legal, see. So those are kind of things that you watch, and that's one thing about NFPA 497. It warns you about a lot of this stuff, see.
Yeah, and just to let all the viewers know, so what we have when we're dealing with these hazardous locations, we have like a fire triangle. So you have what you were talking about earlier, sir. You're talking about heat. You're talking about fuel, and you're talking about, so like when they bring, I can't exactly remember the exact fire triangle, but you have that 3 parts of the fire triangle. So once you bring in the ventilation, now that decreases your fuel. And so it's a less hazardous location. So even if you create a spark, it's not going to ignite. So that's how they can declassify it to a class 1 div 2, because it's more ventilation decreases the fuel that would cause a incident from the heat spark in that area.
Yeah, you're exactly right. And in the oil industry, they'll do that. They'll use ventilation and gas detection systems and use them singly and sometimes together to accomplish what they're after. But yeah, that's correct. And the only thing, you can't take the gas and say, well, it's too lean, but on its way to be too rich, it's very dangerous.
Right.
I mean, it'll get you. I was appointed chief for about 3 months, and I coached with this guy named Garrett.
Uh-huh.
Well, he went out to a little old automobile shop that painted cars, and he made the guy mad. So the guy run him off with a shotgun. So he calls me, and he said, hey, there's a real nice old man out here where we've annexed this little place, and he wants to talk to you. So I go out there, and I show him my ID, and I think I'm requested. And he said, did that fire chief send you out here, son? I said, well, yeah, matter of fact, he did. He said, well, did he tell you I run him off with a shotgun? I said, no, he failed to give me that part of the information. I said, no, I didn't know that. But the old man was smart. He had these windows up at the top that he could crank and open up, and the air circulated through there. So he told me, he said, what's the matter with this place, son? And I saw these Dearborn heaters. So I said, well, that flame there is very dangerous. It could cause an explosion or a fire to occur. And he goes over there with his spray paint, and he just sprays it, puts it out. Too rich, right?
Mm-hmm.
But at the back, I noticed this building door, little area where they'd open the door, go in and spray certain parts. Back then they didn't have all the materials and things they had today. So they would take parts in there and spray it so lint stuff couldn't get on it and leave little dots, that you could see, little specks. So I was watching them back there, and I told him, I said, well, I tell you what, I said, I'm going to agree with you entirely if you'll go back and open up that door, close it, go in there and spray, and we'll just throw a match in there. And he said, the hell I will. He knew, see, that we'd be above the lower flammable limits on its way, but being too rich. And that's when the explosion is bad. So you're either too rich or too lean. So we keep it too lean. So that's what engineers do. They'll take about 25% of the lower flammable limits, which you can find, you guys, in table 4.4.2 in NFPA 497. Everything's in that table. I'm telling you everything. It'll tell you if the gas rises, settles. It'll give you everything that you need to know, the group and everything for the particular gas or vapor that you're dealing with. And there's about 4 or 5 pages there just loaded with the different types of flammable and combustible materials that you and I deal with every day. And with that thought in mind, we'll go to the next one.
So did he chase you out of there with the shotgun after that?
Oh, no. You know what he did? He got to laughing. He got to laughing. He said, he said, son, you're all right. He said, I tell you what, we are in the big city now. We're not, we're big folks now. So he said, you tell me a minimum what I have to do, and I'll do it. And he did it. 2 weeks. He called me and said, they've fixed it and everything. I went out there and looked at it, and he did everything I asked him to do.
Nice.
But I did give him code sections. I said, you read these, and if you disagree, you call me, But he
and
did.
All our listeners out there, all our members of the NEC for Dummies, they always make the inspector give them the code section. So I love you for that, sir.
That's good. You have less arguments, you know. If you
Yes,
go in
sir.
there and just tell them, because I told you so, you can see the hair raise up on the back of their head. You know, you leave a sour taste in their mouth. What happens?
Yes,
Fellas,
sir.
what I'd like to point out here to you, that what we're going over now is recommended requirements, not required yet. But everybody that I pretty well talk to out there, they will use a label every 25 foot on your raceway systems and your cable trays, but inside where they terminate, if it's non-incendive, they use a light yellow.
Okay.
And once again, 504.70, 501.15a, you get in those section seals are not required for non-incendive. With that, you're connecting to some kind of a pressure line that could force vapors back through the core.
Okay. Oh
So
wow,
same.
we have this comment coming through right now. Oh wow, awesome.
No,
All
bro.
right. Yeah, cool. We're gonna
All right.
start that one. That's awesome.
You got to put that in there now.
Yeah.
Now, notice then, fellas, it's light yellow. And we would want to make everything light yellow where we terminate. But again, I've seen them use solid yellow cables for non-incendive. And then they would just take a cable and just kind of spray it light blue. And then they had in their PM manual that light yellow, light blue were non-incendive, intrinsically safe. You're not to work on them. You're not to touch them without you're qualified to do so and have a reason to do so. So this
Nice.
is recommended. Now, don't get mixed up and say, well, now this is required. No, it's just recommended. Go to the next one. Now, looking at this, also, if you go to Article 100 and 500.7 I and J for selecting your equipment, notice that all emerged type equipment where the contacts that are immersed in oil can be used are hermetically sealed contacts. And you can use those in a Class 1 Division 2 area with general purpose enclosures. You'll see that quite often in instrumentation and anything with a very light, voltage. Go to the next one.
That's awesome. Great information.
Now, this is one, if you ever use it, of course, we're not using this, but this is gas detection system, 500.7K in the code, K1, K2, and K3. But if you're in the oil and industrial business, in the oil fields and refineries, you'll go to the API 500, and there's your section, 6.3.2.4.3, and so forth. At 20%, you're going to detect and the alarm sounds. At 40%, you shut it down. And they're that's in the 2023 also. They're putting that 40% in. For
Yeah,
gas
and I think that's a UL standard too on some of that stuff.
Yeah, they get it from the API. The API is the one that come up, with all this. And then, of course, the API says frequency checks on gas detection systems should be every 3 months.
Okay.
And if you guys ever look at the API, or excuse me, 70B, the maintenance standard for electricians where you do maintenance, all you got to do is look at the Annex L, make note of it. Annex L to 70B will give you all your frequency checks, your inspection procedures, and all that, and refer you to the section that gives you additional information. And that covers just about everything you guys will do from the substation right on into the building, and with the different components and things that are installed in assemblies and things and industrial machinery and so forth. So
nice.
Kind of look at that. The L's good. And then if you get into over, say, 1,000 volts, look at the Annex K. You're in business because it'll send you everywhere you need to go from right there.
Awesome.
And this is our last. Go to the next one, James. I think this is it.
Well, oh yeah,
awesome. I've kind of went through what I was supposed to go over with you. I thank James and Bill for having me, and hope you guys picked up a little bit of something from this presentation. And if you ever decide you want the Persian pressurized, and you just get with Bill and James, and they'll give me a little time, about this length of time, I'll go over it with you.
Dude, we
I'll
might be
make one comment.
we might be stealing some stuff from you, sir. I'm not.
I will make one comment that he was making reference to, and he was talking about the maintenance and looking at table K and table L. In chapter 23 and 17, I think also, we have reference in there when you're dealing with this type of equipment in our 70B publication, and ties those tables in with it.
Another comment coming through.
So, because a lot of people don't realize that, and that's, a lot of people don't think 70B's a really big standard, but it's about to be. And when you start looking at just a presentation like this, and how many times he made reference to 70B, especially as it pertained to maintenance, and then you had to do frequency checks and stuff every 3 months on the your gas detection equipment. That tells you right there, it's probably a good idea if you're working in these type of locations, you want to sort of bone up a little bit on that 70B standard.
Well, yeah.
Closing for myself, Bill, if you and James don't mind, you guys, if you want to go over this intrinsically safe versus non-incentive, a little bit more depth, just type in James Gray Stallcup, that's me, senior, and I'll come up on YouTube, and you can get on there and review it more in depth. And if you guys do get on there, well, hit that subscribe button and help me out. I sure would appreciate you doing so.
Build up that following, baby.
And and you can like and subscribe on here too, and then we'll keep you up to date. We'll post links up in our
okay, James can post it for you. He'll get it for you.
I'm gonna tell him. I'm gonna give him the Hulk sign. Smash.
There you go. Smash that like, baby. All right.
Well, smash it, baby.
Well, thanks a lot for you guys having me, and I enjoyed being with you folks out there, too. Thank you a lot.
Thanks, Dad. See you later,
awesome,
brother.
Sir. Awesome. That's so cool. That's so cool. And I mean, just to have him even show up and just, it's cool, man. Like all our viewers, they were only here for him anyway. We're just like the sideshow. We're just like the...
Well, yeah, when he's on, it is. It's like I tell everybody, that man's got so much dang knowledge from, 50 plus years. And, he's been an instructor forever for NFPA. And he's been to all the huge companies. And he's been, star attraction at all these shows and everything where they have conferences and all of that. And they have him come in and do it. I remember when I was like 20 and we went to Vegas and he was doing the code changes, and there was over 500 people in the audience.
Wow.
I mean, that's pulling it, and that's all they could fit in that little auditorium they had at the time.
Wow.
He probably could have had more in there. So
that's awesome.
All right.
Well, are we gonna roll the myth of the week?
Yep, let me cue it up, brother.
Roll.
It's time for Myth of the Week.
All right. Well, what a great week we had this week. This was so awesome. Last week we did Raceway and a Raceway, and we had a lot of comments last week. This week we had a lot of really great comments, really intelligent responses. I was really happy. And we always run into this where you have like let's just say an AC condenser, and then you have like a pull-out disconnect, and everyone's like, oh, well, that's a code violation because that disconnect doesn't have 3-foot working clearance. Well, what we're saying is that that's not likely to be worked on energized. Now, we can't sit there and say, oh, well, now we have to put it on GFCI protection because somebody might not lock it out and tag it out. I mean, if you're saying that, whatever. I mean, I'm not agreeing with that, but I mean, we're qualified individuals. I actually am a qualified electrician, and what I'm going to do is I'm going to lock it out, tag it out, and I'm not going to work on it energized. A lot of this stuff where we get in these arguments, they have control panels. The one that I showed, do you have that one I showed with the VAB unit where it has like the 30-inch clearance or whatever?
No, I don't have that on here. I forgot.
Yeah, no big deal. But anyway, we had this VAB unit. It's up in the ceiling, and it has 30-inch clearance to a brick wall. So, they're like, oh, well, that's a code violation. Well, they still have to put grid up. They're still putting ceiling grid up. So you have grounded materials in your working space. So to me, the only way that could be code compliant is to say it's not likely to be worked on while energized. And then the other thing is that one of the listeners, one of our viewers actually pointed out to me, which I thought was amazingly brilliant, is he says, yeah, those VABs, you can't even open the door unless you turn it into the opposition.
That's right.
So that's telling me the manufacturer makes it to where it's an electrically safe work condition. Now, if you turn that switch off and you open that door, is there still energized parts in there? Probably. I mean, are you still exposed to arc flash? Probably. I mean, so you should probably work if you're checking those fuses. I argue this all the time, and people say, "Oh, I have to work it energized, Willie." Okay, well, guess what? Anything that I do in the electrical industry, you could test with the meter, with it being de-energized. I mean, if you could come up with one example where it has to be hot and you can't test it with a meter, I'm telling you, you don't know how to read your meter. That's what I'm saying. That's my position. I do a lot of fire alarm, and when we're in fire alarm, none of it's energized. We're not working on live systems, and then guess what? When we put power to it, it all works because I can tell with my meter that everything's going to work. So it's the same way, whether it's fire alarm, whether it's, high voltage, 100,000 volts, so I don't agree with working on energized. Now, I get it. A lot of the linemen out there, they have to work it energized. They have to leave it hot. And they have a whole different standard that they have to adhere to. But us being what we call inside wiremen, we try to keep it to where we are putting our employees in electrically safe work condition. And, from time to time, we might joke around and act like we're working on stuff energized, but we're in an electrically safe work condition, making a joke. And I guess if people don't get it, that's fine.
Sure. When we sort of look at this from the 70 committee, I remember I was, somebody tagged me on a video. Do what? Oh, yeah. He was asking me something. Whenever we take and do, somebody tagged me on a video, and he was talking about the clearances in front of the equipment, and he said that's the arc flash boundary. And when I got tagged, I listened to the video, and I commented. I said, no, I said that isn't correct. And I went through and did a full detailed explanation. And the next thing you know, he come out and did another video and did it the way I said it. Right. But being on the 70 committee all these years, I mean, pretty much, I guess we're on it since it started. When we started on the 70 committee, basically all it was installation rules that pertain to safety, and it was in direct compliance and matched up, sort of mirrored what the OSHA standard said when you were looking at OSHA 1910 point 303 through 308. And then we started getting into the arc flash, arc blast, and all that other stuff.
Well, we might have to just get a little arrow pointing at your little figure there and say Lemonhead. Mm-hmm. And he'll be our official character. We'll just make a Lemonhead for all your illustrations from now on.
Okay, well, me, the thing, when I'm putting these illustrations together, I went through probably about 50 combinations of different colors in order to get it to look a certain way.
Okay.
And when it comes to a person that's on there to separate from the face and all that, it's easier to do a yellow hard hat, or I could do a white one, but uh, you got to be careful because a lot of them have black hair or blonde hair, so you try to make sure it doesn't blend into it.
Okay.
So there's a lot of things I look at.
All right. It's Lemonhead.
All right. Now, when we start looking at this, basically we just tell you this. When you actually go over and look at 110.26A2, this is where you get the width of the equipment telling you got to have at least 30-inch workspace. Now, what we did in our illustrations, and as anybody that's still on here that was watching the presentation that Dad did, you'll notice we always have a lot of code loops and stuff that we put together for you to follow. So we tell you here, you have your spaces about electrical equipment. Now, these spaces about electrical equipment per 110.26A, this is where it's going to get in. It's going to tell you this is equipment that you're likely to work on while it's what? Energized. So if I'm looking for the depth of the equipment, I'm in 110.26A1. If I'm looking at the width, I'm in 110.26A2. And if I want the height, I'm in 110.26A3.
Gotcha.
Okay. So
Awesome.
we put those in there so you can follow what's happening here. Now, what I like to point out, as I was saying, if you look at 110.26A, and it'll talk about the working space. Now, I want to point something out also before I go any further. When you go over and you look at the NFPA 70E document, and we start talking about energized conductors and circuit parts, that's how we reference it over in that document. Okay.
Yep.
Here we just tell you doing it while it's what? Energized. But over there we tell you energized conductors or circuit parts. Okay.
Yeah, so like if I had like an energized 4-square box, I wouldn't need to like do anything different. It's like there's no exposed energized parts, right?
No, there's not. And
okay.
Now I have heard this before. I was trying to remember, there was a company, I think it was Seattle, if I'm not mistaken, but somebody gave me a call and they said, they're telling us that we're in a hazard risk category 1 if I have to open up a box.
Okay.
And a junction box. And I said, no, that's not true. And he said, well, they're saying it is. I said, now, if it's their own safety manual, they won't go that route. That's fine. I don't really care. Yeah. But to say, he said, they said 70E says it. I said, no, it doesn't. And I said, when you look and you're doing a hazard risk category and you're looking at the NFPA 70E document, okay, we're going to tell you certain specific equipment. Now, I want everybody to listen to what I'm saying here. If that piece of equipment and that type of task you're going to be doing is not listed, then that table does not apply at all. Period. Okay. That's in the discussion. It does not apply. It's not a hazard risk category. And we actually come in and made changes. I remember a while back, there was a couple of us that were only doing the 70 classes for NFPA. And the reason that happened was because we had some other instructors that didn't fully understand 70 at the time because it was new, the stuff we were teaching. And they were saying, well, just pick a task that's similar and then apply it to that hazard risk category. Well, that got back, and of course, 70E committee found, we said, no, that's not right. And I was actually helping on the task groups that put those tables together. And when you get in and you start looking at this, we specifically now let you know if that specific piece of equipment and task is not listed, that tables 130.7 C15A, B, and C do not apply.
So, question: is there such a thing as a risk category 0, or that just because I thought
it's gone?
Didn't they used to have that?
They did at the first. It's no longer there anymore.
Okay.
And what was funny when they started making those changes, and this is true, some of the 70 guys might be mad at me, but they'll remember I was the only one that voted against that when it came out. And I said, that hazardous category 0 is going to cause problems, and it's not ready to change the table yet. And because we had already changed the table the cycle before. And they said, well, we're always updating, blah, blah, blah. And sure enough, they come back the next cycle, took it out, like I said. So those are things, being on the committee a long time, you learn these things. Now, I will point out, if you look at the working space there, the text, it says working space for equipment operating 1,000 volts nominal or less. It says to ground. Now listen to it. And likely to require examination, adjustment, servicing, or maintenance while energized. Now,
with exposed live parts too.
Right. Now I want to point something out here. Right below that, there's an informational note here, and it tells you to go see what? 70. Now, the reason that that's in there, we've added a lot of informational notes all through Article 110, that reference going back to 170. It can be for dealing around working space. It could be for your arc flash warning to tie in with 70E. It could be your available incident energy. I don't say your available incident energy, but like your available incident energy or short circuit current, whatever you want to call it, 110.24 and then 110.16. They all have this reference to go check 70E out. Okay.
I really liked what you said on the last podcast about the clearing times.
Yeah,
that was a good one too.
Well, what that gets into is, now I will point this out since you brought it up. Whenever you're dealing, it doesn't matter to me if you're using the hazard risk category, which is the tables, or you're doing the calculation method in Annex D. There's two values you're always required to have. And what are those values? You got to know that available incident energy. And what else?
The clearing time of
clearing
the
time. To do the calculation or apply the table, you need to know that. Okay.
And I really like when they go into like the 0 point too, because that 0 point is predicted. It's not an absolute value.
That's right. Now, the interesting part about this is I'm looking here and I'm just dealing with working space. Okay. And at working space, we're telling you to look at 70E. And the one thing I want to point out here is it'll talk about determining severity of potential exposure, planning safe work practices, including establishing electrically safe work condition, arc flash labeling, and selecting PPE. Now, what I want to point out, it's one thing to have the clearance to be able to work on something while it's energized. Okay, we're all going to agree with that at this point. But if I'm working at energized, this working space has nothing to do with the limit approach boundary, the restricted approach boundary, or the arc flash boundary. All four of those are separate entities.
Yeah.
Okay. And I'm going to show that here in a minute. Now,
so we ran into this when we were out in gas and oil, and I was blown away. Like I was literally blown away. I was shocked. Let's just say I was shocked I was shocked in an electrically safe work condition when I went and tested this out, where we went and saw what 5 foot was. So if we're at 5 foot, we're at the limited approach boundary, and we can test for the absence of voltage. And we don't need we don't need to be suited up. We could just have a hard hat, safety glasses. We don't need an arc shield. We needed to have FRs that's full length, full sleeves.
Right.
And so we could go into that limited approach boundary and test for the absence of voltage on 4160 at 5 foot. And so that was the whole reason I did that. Whole picture was because I wanted to show that with the 70E teacher telling me, hey, dude, if you guys want to, mess around, we can mess around. It's electrically safe work condition. I was like, all right, let's do it. And so I did that strictly for learning purposes. I wasn't trying to do anything dangerous or put my company at risk for, lawsuits or anything. Like we were just trying to show something. None of that gear was ever energized, ever. had never been energized prior. So
You
I
know,
thought it was a good opportunity to do that.
and I remember looking at the video he was making comments on, and the first thing I pointed out is, how can you even make an assumption what the arc flash boundary is? Because it was where you could rack in and out, and actually one of the other parts of the calculation, and also using the table, is the distance where the connection point is. Well, this was further back in the equipment, so you got a bigger distance. That's going to take and limit that distance. Of course, it depends on how much pressure can build up inside that enclosure and push it out. But they will take and give you a distance based on those three values to do your calculation in NXD.
Well, and that's why I did that picture. I wanted to show that that piece of PVC he had was, I think it was like 5'6". So he was holding it. It was 5 foot long, and he was touching the energized parts. So I mean, that's pretty far back in the gear. I mean, you could tell it was like, oh man, there's not even close to enough room. Because that's instantly what I thought. That was the first thing I thought. I was like, man, I got to take this picture. This is a code violation. And the 70E teacher was like, dude, who's telling you that? And I was like, what do you mean? He's like, who's telling you it's a code violation? I was like, well, that's what I thought. And he goes, nah, dude. He goes, well, for one, it comes off the energized parts.
That's right.
And then he goes, go look at this. And he shows me the table. And if you're going to use the proper PPE for that installation, like he did the calculation right there. He's like, well, this equipment's this and this and this, and it's going to have this and this and this. And boom, here's your clearance with a 40 cal suit on 12 inches.
Yep.
And so that's plenty of working clearance.
That's right.
So any engineer in the country can engineer a system with 12-inch clearance, and it's legal as long as it's not likely to be worked on while energized or examined while energized. So
that's right. And those are the things that you look at. Now,
absolutely.
As you look at A1, this is the depth of your working space. Now, when I'm looking at doing my working space and I do my width, depth, and height, what is that to protect me from when I'm working on it energized?
Is it shock or arc blast?
Shock protection. That's it.
Okay.
That's all it is. It's shock protection. Okay. Now, this is just sort of showing where we'll just say that I'm in condition 1 and I have a 277 408 volt system there. Okay. So we're at 277. Condition 1, what's my clearance in front of the equipment?
I'd say 3'6".
I'm in condition 1, not condition 2.
Oh, okay.
3 foot.
Yep, 3 foot.
Yeah. Anything in condition 1 is always 3 foot.
Okay.
Now, I want everybody to see this. Now, what'll happen next is right back where we were looking at 110.26a, and I picked up the informational note number 1. It said C70E. Now, I'm going to take the exact same thing here. Now, we're working on a exposed fixed circuit part here, and we said it's 277 volts, right? Now, if I come across and look at my limit approach boundary, what does it tell me I need to be? 3.5 foot.
Yeah.
Okay. Now, I want everybody to listen to what I'm about to tell you. That right there is the very minimum your barricade can be.
Yep.
That's to protect you and unqualified personnel. Now, if I go across and I look at the restricted, it's going to tell you anytime you're within 1 foot, you'll see right up above that in the Pren 4 up there, it's going to tell you this includes inadvertent movement. And in other words, what we're telling you here, we consider that the same as you're going to be working on the equipment if you're within that distance of that equipment with that voltage.
Nice.
Okay. And that goes in a little further detail explaining that. Now, we even tell you, I'd ask this question all the time in class. I'd say, could an unqualified person enter that area?
Nope.
See, it's a trick question because if they've been trained and you've escorted them, tell them not to get within that 1 foot and walk through there, it's perfectly fine.
Right.
Now, once I determine what the arc flash boundary is, the arc flash boundary can be less than that 3.5 foot, or it can be more. And if it's more, then the barricade moves out to that area.
Right. And you have to have people that are trained in CPR that are a part of your crew. And so those people could be qualified in CPR, but unqualified with electrical.
That's correct. You could have a safety backup, and that safety backup's there to know where to go upstream to turn it off if something happens. If the overcurrent device is too far upstream, then you would set up where you might have a dry rope or a non-conductive pole or something to knock them off.
Right.
See what I'm saying?
Yeah, we use that. We have the chicken hooks usually.
Mm-hmm. I mean, there's things that you can do. Now, what I want to show here on the next one is this is an illustration that we have in our 70E publication. We've got another one showing the ribbon going around everything. I just did one of them just to sort of prove a point here. Now, if you take and you look at that sphere, you're going to see we show you the different types of stuff that's here when you're dealing with this. And we also tell you here in note 5, there used to be a prohibited boundary. That boundary has been deleted, just like hazard risk category 0 got deleted. Okay. Now,
I can't say that was a really awesome category to troll on some people.
Oh yeah,
they didn't read stuff too good.
Now, what I did is, since I already knew what was here, I went ahead and used the right voltages and everything.
Okay.
You'll see here, I'm asking a problem here in the step 1, the solution, and I'm asking you, what is the limit approach boundary in feet where there's a fixed exposed circuit part, and we say it's rated 480. What is it? 3.5 foot. Okay.
Yeah.
Now, if I was in the restricted space, what would it be? 1 foot.
Yep.
Okay. Now, I also want to put here, you'll notice in note 2, we tell you here, untrained personnel shall not be permitted to cross the limit approach boundary. But there is parts in there, if they've been trained and they know what to stay away from and they're escorted through that area, you can do that. But let me point one other thing out. If that arc flash boundary extends out to that area they're walking through, guess what? They got to have that PPE on.
Yeah, and I was just gonna say too, with that 12 inches, because that's when you're wearing you're dressing for that condition.
Sure. But I think this is a good way to go in and show what the difference is between the working space requirements by the NEC and then looking at the 70E, tying it in with it to show the boundaries are all separate from each other.
And one thing I want to emphasize to all the people that's watching the High Voltage Live show right now, when you're putting on that, let's just say you got PPE and they say, hey, put on an arc flash suit. Mm-hmm. That is not a Superman suit.
No, it ain't.
You have to remove all metal objects. I mean, I tell you what, Willie would have his pants down to his ankles inside an arc flash suit because I have to take off my belt buckle. And by the time I got done, I'd have plumber butt all the way out that arc flash suit. So everyone knows that about me. I got plumber butt all the time. I did plumber butt when I did the water trick, and I drove ground rod with a water bottle. I'll challenge any apprentice for a breakfast burrito.
Oh yeah.
Drive a ground rod with a bottle of water.
Let me point something else out about PPE. And a lot of people don't know this. And anybody that watches this video, you need to listen to what I'm about to tell you here. When I was, on the 70 committee, I remember when we started this and they were providing documentation and everything else for us to look at. And, Dad and I had already written a 70E book, and it was based on uh, the installation safety requirements with OSHA is basically what it was. It was called the Red OSHA book at the time. And
Okay.
they started adding all this stuff, and we had to figure out some calculations, put all these new illustrations together. I can tell you, we were the first to ever write a 70 book, period.
I believe it.
That's a fact. And we're the only ones I know of right now that even has a 70B book. But when you go in, and we were sitting there listening to it, and I was reading through the documentation, and basically when the PPE is calculated based on the cal rating, okay, now once that cal rating, incident energy level, is determined, that is based on, as a person wearing the PPE, that you will not receive more than a 2nd degree burn. Now,
Wow.
I'm going to tell you
Wow.
that hurts. And
Wow.
but
Yeah.
it's considered a curable burn. So, you
Right.
know, I've been to facilities all across everywhere. We've been around the world. Dad and I have. And I will tell you this. When I tell people that, they're like, "You mean I can still get burned?" I say, "Oh yeah." And so,
Dude, you can still get your arm blown out of the socket.
oh yeah.
You know what I
And
mean? Like, I mean, you can't be. It's not a Superman suit, and
it's
the
not.
thing that you got to realize is all metal objects must be removed. So I got to take my keys out of my pocket. I got to take all my
Sure.
change out of my pocket because there's no metal objects allowed in that restricted approach boundary. So it doesn't matter if you have a suit on or not. That suit's not protecting you. So are you going to get your leg blown off because you left your keys in your pocket because you wanted to unlock something
Won't
later?
do it.
You know, I'm
Won't
not
do
doing
it.
it. I'm treating
And
it like I'm going to the airport and I'm putting everything in a change thing or whatever.
hell
And
yeah.
I could get it back later. But my problem was taking the belt buckle off because I hate taking my belt off. But you have to do it because that's a metal object in a restricted approach boundary.
I actually bought a non-conductive one that when I went to different places that wanted, when this all first started, and they were wanting us to come out and look at their safety programs and help them write them. You know, a lot of people don't know this, and Dad and I are the ones that do the update for the Department of Energy and Defense's safety manual. We're the
Wow.
ones that did it for them, and
Nice.
the reason that is because they saw we knew what we were talking about, and we do a lot of classes for them. I mean, we go to a lot of different DOD and DOE.
Dude, I'm not saying that that's a good idea, but I think it'd be kind of cool to have some big old Texas belt buckles that are non-conductive, or so
I
I
got
could go.
2 of them.
All right, send me one, man. I'll sport it around. I'll be like, I'm James Stallcup. That'd be cool.
Yeah. But
That'd be
anyway,
nice.
what I like to tell people is it doesn't hurt anything to put some extra cal on.
Yeah.
I mean, be more safe. I don't want a 2nd degree burn. I can tell you, no way I want that.
Well, and just letting everyone know, we all have the authority to stop work. We are all responsible for our own safety, for everyone else's safety. So if you think something is unsafe, it probably is, and you can shut it down.
Take a step back and review it again.
Should we go to the code changes now?
Yep. Let me cue it up. It's your favorite song. You ready for it? I know you love this.
You know what I'm gonna do is I'm gonna learn a metal song, and I'm gonna play a metal song to it, and then I'm gonna send it to you. I'll record it, and we could still run it, but it's gonna have metal. It's gonna be the metal version of that.
One thing I want to do, if I sound like I'm tired, everybody, I'm telling you, I'm tired. I, uh,
Dude,
last night, I've been up for 36 hours straight, and I had to get all this ready last night, and then I had to get
dude,
more code changes because we're
this is
trying to
so
finish the book.
awesome, dude.
And
Dude, we've had the
I can
most
tell you,
viewers ever right now. I mean, we've cracked 10 all the whole entire session. Like, dude, this is so awesome. Like, everyone's on the edge of their seat. Like, what's next? What's next? So it's cool.
oh
I
yeah,
love it.
it's awesome. And I'll tell you, we just finished chapter 6, and they're doing the illustrations and stuff now. And all I have left to write is chapter 7 and chapter 8. And usually there's not as many changes like those first 6 chapters. I mean,
Right.
and I will tell everybody this: we're going to be over 250 new changes. And like
Nice.
Dad was saying a while ago, they've changed all these table numbers and section numbers. Stuff has been moved around. I'm just telling y'all, if somebody put a code change book together and it only has 100 changes in it, don't waste your money. You need to get one that has a lot of the changes in there, because you need to be aware of what's taking place in this cycle. There's really a lot of changes in there.
So
Okay.
what
All
are
right,
we
let's get
covering?
to the next portion of the code changes.
Where are we at now? We're at 240. All right.
We're at 240.7. Yeah, we
All
got
right.
to 230 last week into the start. I think we went to like 240.2, if I'm not mistaken.
Okay.
And what they did here, this is dealing with your overcurrent protection devices. Of course, you're in Article 240. And what it's going to talk about is the listing requirements. And what they did is they tell you that any of your branch circuit overcurrent devices have to be listed. And basically, I actually feel this is good, and I'll tell you why. Because it was always just interpreted and assumed that it had to be listed, and the authority having jurisdiction would want the marking on it to show that it was a listed type device that was being used.
Right.
Now they put it in here, and then they did have the relays and circuit breakers providing ground fault protection in the first revision. And I don't know how it got missed, but they came into the second portion that they did in the second revision. They added it back and also added the ground fault circuit interrupter devices, also saying all 3 of those have to be listed devices.
Dude, you do not want to see the GFCIs that Willie Jackerson is making, man. They're a sketch, man. A sketch. It's got a listing on them, but they're sketch. I'm not buying it.
Oh, well. Now, what they also did here is selective coordination, and this is where they're talking about one or more feeders. And basically what they're trying to say is you have your service overcurrent protection device that's upstream, and they're telling you that they want to take and make sure that these feeder overcurrent devices are selectively coordinated with that service overcurrent device.
Yeah, that's a good change.
Yeah, it's a damn good change. And and you know, engineering and stuff, they would do that, you know.
Yeah.
And but you get an electrician out there, and he doesn't pay any attention to that a lot of times. I'll just tell you, they don't.
We had a job. I'll kid you not, man. We had a job where ground fault happened in the system, and it went all the way out and blew up the transformer. And we had to redo that whole.
It wasn't coordinated, was it?
We had to go redo that whole service, and that's where I learned about it, because I was like, okay, why this happened, you know? And it's like, because that overcurrent device should have opened. Dude, they said blue flames came. They said purple flames came out of the transformer, and then it blew in half. You know,
I believe that.
How does that happen? I mean, they just had basically the whole entire building like main lugged. You know, like it was stupid.
They did, and that's why I think this is a good change. I think you know, and this is something when we're out doing our code changes stuff. This will be one of our top 100, because this is something that that anybody that's out there doing any type of wiring or anything, I don't care if you're a contractor or whatever, you need to be aware that that service has to be selectively coordinated with that service over current.
Yeah, and it's not hard.
Okay.
You don't have to be an engineer to do it.
No, it's not. Now, this one is really not a change. Okay. What this is, this was an Article 100, and they've taken and added a new section here, 240.16, and they're just telling you that those branch circuit overcurrent devices shall have an interrupting rating not less than 5,000 amperes. Okay. Now, personally, I think this is a great change. And the reason I think that is because I've always maintained this, that I always thought if you're dealing with the branch circuit overcurrent devices, you want to have it in Article 240 to explain what those interrupting ratings are. They do the same thing when they're looking at Article 110 also, when they're doing general requirements. So I always thought this should be here instead of Article 100. So based on that, I thought this was a really good change. Now, what you got to pay attention to here, this is mainly the exception, and this is where we're talking about the accessibility of the circuit breakers and switches that can be contained in fuses. And this is where it's located in or on the premises, telling you that it has to be readily accessible. Okay. And then, of course, we got our 6'7" to the handle when it's at its highest position and all that. Now, when you look down at the exception, what they're going to tell you here is they've added some new material or new structure here, I like to say, because we always had the use of a tool shall be permitted to access overcurrent devices. But what types are they talking about here? They're talking about industrial control panels within enclosures designed for hazardous classified locations or enclosures to protect from what? These are environmental conditions. Okay. And basically what they're saying, these things are all completely shut. See what I'm saying? Yeah. You don't really get into those. They got little screws all the way around them and everything. And they're basically saying you're using a tool to gain access to that. That's an exception to permit this. But I also want to point this out. That last sentence is going to talk about when you're doing this, that's fine. We permit it and everything. But all the accessibility requirements and that is right above it in 240.24a there are going to apply also with this exception.
Do you know what this comes from?
Yeah, it comes from the hazardous location people and all of them because they got to have access to it.
So we made a billy bolt for hazardous locations that is a nut and bolt that keeps the enclosure shut so people don't just go over there and open it, and you're going to expose those make or break contacts to a hazardous location. And if you can use a billy bolt or you can use a lock, but the best one was the billy bolt because it works every time.
Yeah, and I will say this, and it depends on the type of equipment. Also, you get explosion-proof type equipment, you don't need no billy boat or nothing. You're going to be taking a lot of boats off to get into that sucker because everything's contained inside, and then you'll have your seal-offs within 18 inches of that equipment.
Yeah, so, this was in a Class 1 Div 2 area, but it was still, I thought it was cool because you could easily take that bolt off, but you had to get a tool because it had a self-locking nut. Like you weren't going to just take it off by hand. You had to get a tool to get that loose to get that door open. But by the time you did all that, you're going to realize that if you open that cabinet, you might end up over there in Texas hanging out next to you. You and Pops.
Oh, hell yeah, you will. Okay, now this is the last one. This is more of a clarification than it is anything. I don't consider this one of the top 100 changes, but it's something that did need to be brought up because it's going to talk about your overcurrent devices, which are other than your supplementary. And this is where they're located within the equipment it protects. And this was always in there, shall not be located in bathrooms, but they also added the showering facilities or locker rooms with showering facilities. They're telling you not to locate them in these areas. And the reason is because it's, you got water and everything splashing everywhere. So they want to do a clarification just in case, say, like you had a healthcare facility, I don't say healthcare, but a workout facility, and they went in there and put a panel board in there where everybody dresses, gets ready and everything, and all the shower and stuff is in there. That could cause a problem.
Yeah, absolutely.
Okay?
Dude, that was awesome, man. Dude, you crushed it. Man,
Hey,
that is,
man, I'm
that is-
trying to live up to that.
dude,
That's
I'm
hard to
telling
do.
you. I'm telling you, man, dude. Dude, this whole thing drives me like, I mean, I'm probably on not much sleep myself because I'm working and trying to do the change of the week or the
Sure.
myth of the week, and I'm trying to just put as much together. I got so much metal, dude. I have like so much metal saved up. I'm like trying to send them to you. They're not going through. So I'm trying to figure out how to, get some better to where I can just send you some wave files when we get
Well,
this together.
it's like I tell people, a lot of them, you see the podcast we're doing everything, and you can see all the cool graphics. We always have presentation and everything. There's a lot of work goes into that. And
Dude, we're doing this as a hobby, just so everyone knows.
yeah,
We're doing this as a hobby. Like we're not making money off this. Like, and the thing is, I hear all these code guys out there that's like, I don't do anything for free. I don't whore myself out. Okay, cool, whatever. But the whole thing is, it's like, I mean, we don't look at it that way. We like teaching people, and if you want to learn, cool. If you don't, then why don't you go over to TikTok and like say you're great at parties, whatever. But I'm just joking. Like the whole thing is we love all the people that tune in every week, and this is awesome. And we try to give you a well-rounded thing where we're dealing with tools, we're dealing with all kinds of different stuff.
topic, myth, code
Yeah,
changes.
I'm trying to
We
bring
were
it in. I'm trying to bring it into the real world. Like all my myth of the week comes off real world. Like I posted in the group. And you'll
Sure.
see, like that's stuff I seen out on the job site,
I can tell you, there's a lot of people that are watching this podcast. We don't have we probably might have a ton on right when we're doing it, but the views that come in afterwards, we're doing over 65,000 views. I expect that eventually to get up to a couple 100,000 once people start figuring out more and more. And I look at it from a different point because I get a lot of calls and they're saying, hey, can you come out to the facility and go over this, and this for our guys? And that's how one of them here in Texas, right over here, Trinity River Authority, they actually are watching this, their supervisor, and he had me come over and do a course for them. And from what Dad said, he says he thinks Leviton's been watching, and that's why we're doing the Leviton pamphlet now for them for their type of equipment for the code changes for.
I love that pamphlet too. I run that pamphlet on Myth of the Week, so not on Myth of the Week, but I run it on Nat King Code.
You're going to get to run it this next time with the Stallcups on it.
Yeah, awesome. All right, let's talk about tools. Tool time.
Let me cue it up.
It's time for Tool Review of the Week. Sponsored by Electricians Only Tool Review and Nipex Tradesman.
All right, this is one of my best reviews that I can do. I actually own this fish tape. It's a great one. It has laser etched markings on it, stainless steel. I don't think mine still has the little curly Q cool thing on the front. Like I think I lose that like almost like right away. Mine always gets like a kink, like right about 10-foot mark where I'm trying to do weird stuff and hook it and pull it through, whatever. But this is probably the best fish tape on the market. It has the links laser etched on it, and so it's really nice. Like sometimes you could go into a conduit you could go so far, you could hit something, and then you could pull it back out, and you could look, and you go, oh, I went in 60 foot. And you're like, oh, that was right where Cletus Jenkins was putting in a 90 or whatever. And then you know pretty much where the problem is. And then the other part that I really like about this one is that it has a really good warranty. I had like my first one that I got, there was something stupid that happened and something got tangled up inside. And I took it back to Ideal and they were like, no problem, here's a new one. And they handed me a brand new one on the spot. So I'm really happy with Ideal. They've done a great job. Their customer service is great. They answered the phone right away, and they got me a brand new fish tape right away. And I thought that was awesome. And you know, a lot of people say, "Oh, we don't have to provide our own fish tapes." Well, I'm not doing it just for me. The fish tape that I got was given to me as a gift from my employer, and you know, it was like, "Oh, you pulled like 9,000 foot of wire. You deserve." Just keep the fish tape, you know. So it was kind of cool. And then I registered the warranty with them and stuff. So I ended up with my own personal fish tape out of the deal, and I didn't have to buy it. Pretty much got it for free. But I would say hands down, out of all the fish tapes, I really like the Ideal the best. I've used Klein, I've used Greenlee, I've used all of them. They all are great. I don't have a bad review on a fish tape. The only thing I like about this one is it has the laser etched footage on it, and that's really awesome in a pinch. So nice and short tool time, and we'll get you out of here, James. I know you're tired, brother. I totally appreciate you, man.
I think that's awesome. I was going to point out I'd done some looking over, and NEC for Dummies hit 16.5.
Nice. Yeah.
God,
Awesome.
I mean, I have a feeling this thing's about to hit 20 before we know it. It's like nonstop. I mean, you know, as soon as we do an invite for 300, 400, 500 people, we've already got another 500 a few days later.
Yeah.
I mean, I just want to say to all the members, thank you. You know, when Bill and I decided to make that our main thing to go and do that, we were going to be happy if we got, you know, anywhere between 5,000-10,000 just the first year.
Yeah.
And here we are looking at 20 in 6 months. I mean,
well, and it's really hard because a lot of these guys are like really stuck and they don't let you guys have your own view on certain things. And we're going to be open to that. If you tell me, you know what, that fish tape's an electrical hazard because it's got metal in it, I'm not going to tell you you're an idiot. Like, you're probably right. Yeah, you probably shouldn't push metal fish tape into electrical conduit into a panel. Yeah, it's probably a hazard. Don't do that.
You what, when I was coming up, we did that, and we would take a cardboard, stick it in there where it would hit and angle out. I swear to God, we used to do that when I was coming through the trade back in 82.
Dude, we had one where a dude pushed through a spare conduit. I don't know how it didn't blow up, but somehow that fish tape went all the way down behind all the energized parts and coiled up and turned into a circle behind all the parts. And then he went and pulled it all back out, and it pulled all back out too. And I was just like, when I saw that was an energized gear, I was like, how the hell did you do that, dude? You're a miracle.
You know what I would have told him? I'd have said, son, you need to go to Vegas and bet big.
Yeah, dude. Yeah, it was incredible. I didn't believe it when I saw it, but that's one thing to let you guys know with electrical hazard is do not ever push a steel tape in energized parts. I saw a kid almost get killed doing that, and so glad he didn't get hurt. But I told him, I was like, just push it in the conduit. Don't hit anything hot. And he's like, oh yeah, dude, I don't want to get anything hot. Dude, it wasn't even 5 seconds later.
Was he?
I walked like I just barely got to the outside of the building. I heard boom. I'm like, oh man. I was like, that sounded about 70 amps. Went over there, he freaking the fish tape went over and touched the terminals on exposed wire. That's another thing I always tell people when you're terminating breakers and stuff to not have like exposed copper on the outside of that breaker. Because that's what happened was they had all this exposed copper on the outside of the breaker. That fish tape came around and it touched both those phases or both.
Sure.
Well, it was a 3-phase system, so it was single phase, but it touched both phases on that 70 amp breaker, and luckily it shorted out the sub panel, and he didn't get hurt or anything. He had gloves on and everything, but still, it was like, I mean, it scared the daylights out of me, and it was at a school. It killed the whole school, and I just said, nah. I was like, I mean, I probably shouldn't have done that, but I was trying to be arrogant, and I was like, you know what? I was like, I bet you I could go run all that rigid over there before he even gets a fish tape there.
yeah.
And
That's right.
and I would have done it if he didn't blow up the 70 amp breaker, but it was one of those things that you don't want to try to be doing that stuff in any kind of situation where you're trying to be arrogant and think you're Willie badass and like you're gonna go run a bunch of run 10 foot of rigid faster than they can push fish tape there.
That's right.
I could have done it, but I put somebody at risk, and that's not gonna fly. So stay safe, everyone. Stay safe.
Tell you, we're getting up close to getting to 2 hours tonight.
Yeah,
there was a lot of explanation going on, though. It was a hell of a podcast.
We cranked it out. No,
Yeah,
we appreciate everyone, and thanks for joining us. And everyone needs to stay safe. Always work in electrically safe work condition. Do not ever push a fish tape into an energized panel. That is a disaster waiting to happen.
Sure is. And if y'all got any questions, if y'all want to see Dad do purge and pressurize, we can get him on to do it. I can tell you, we got all the illustrations to do any type of course pretty much you want. So just
and if there's any illustrations you guys want us to post in the group or whatever, let us know, because the Stallcups are awesome about sharing their illustrations. Like, they don't care. They'll let you guys post them anywhere you want. So that's pretty cool. I appreciate that with you guys. I mean, not saying that I already have some in my hard drive that are saved that, I asked you permission for, but, that was awesome on the 2020 code change class. And that meant a lot to me. I can't wait to do the 2023.
Well, I will. I'm probably going to take 1 week. I'm going to do just do a podcast and just go over and show everybody what's coming for 2023.
Do you have any states yet?
Not yet.
Okay.
I think they're coming pretty soon. I don't know why they're taking so long. It's just mind-boggling to me. There's been 4 of them said, it shouldn't be any time now. I don't know if they're having to send it over to somebody, then get approval. I don't know what they're doing.
Okay.
But hopefully,
we could do like an update if you start getting the states in, because a lot of people have been bugging me and they've been trying to like, hey, I need to sign up now, and they want to get it going, So
yeah,
we maybe do an update on it.
And as soon as what I have a feeling, when one starts, they're all going to start coming, and then I'm going to be just pounded. But I'll tell you, I hadn't been checking on any of it, and I'll tell you why. Because I'm writing a code change book right now, so I hadn't been just focusing, because I got to get this code change book.
First code change book out of anybody, brother. That's awesome.
I'll say this: I'll be shocked if anybody has as many changes as we got in this code book.
Awesome.
It has a lot of changes in it. So, but anyway, let's call it night. Hell, we're at 2 hours, brother.
Thanks for everyone joining us. Appreciate you. Thanks for sticking with us. The 2 people still here. That's awesome.
No well, everybody, y'all have a good weekend, and we'll see y'all next Thursday, and we'll have another good setup for y'all. Take care.
Peace. Volt Online Academy, the #1 source for your online materials. Thanks to 2023 Electrical Code Ninja. Thanks to Eddie T for Dummies. Knowledge and Power Learners Today. Thanks to ADC Deathmatch. The Lady Apprentices. Thank you. Thanks to the Electrical Code Discussion for Awesome Electricians. Thanks for being here. Electricians only 2. The true second one. Thank you. NFPA 70E Discussion Group. Thank you guys. Appreciate you joining us. Mark Candell. The Creative Solutions for today. High Voltage Live Electrical Memes. The best electrical memes on the planet. Thank you guys. Thanks for joining us. Appreciate you all.